Hello, my fellow bottom-up information processors. Welcome back to another episode of Low Spec Labs. Before we get started, I would like to say thank you for subscribing, thank you for commenting, and thank you for liking. And I would like to do more than say thank you. I'd like to give back to this community. I don't have much, but I do have a mini bike, so I'm hosting a giveaway. I've already announced this on my channel, and I'm going to be announcing it in basically every video until the giveaway is over. So if you would like to win a free mini bike, please go to giveaway.lowspeclabs.com. That is going to be to the left or to the bottom, depending on how I cut this up, and sign up. It's pretty straightforward. You have to subscribe, like, and comment. Each one of those is an entry in the contest, and the more you do that, the more entries you get. You also have to be able to come to Jacksonville and get the mini bike. So good luck. On this episode, we're going to talk about troubleshooting your Linux system. This is chapter 18 of the RHCSA exam book. We should only have about 6 or 7 more chapters to go before we're done with this series, and we can start on Ansible stuff. We're almost done. This has been a long journey. Maybe only a couple more weeks to months to go. So let's power through. This chapter basically wants us to learn how to troubleshoot grub and boot issues. So we're going to go through that. To understand how to troubleshoot boot issues, you have to understand the Linux boot process. Thankfully, I've got a chalkboard next to me, and we're going to go through this together. Let's start with step number 1, post, or power on self-test. Post is at the lowest level of the boot process. Basically, it is your motherboard starting up, and then we go to step 2. Step 2 is where we either have UEFI or the BIOS select our boot device. Then we get to step 3, and this is where we load our bootloader. After step 3 is step 4, where the kernel loads and is initiated. And then we have step 5, which is after the kernel loads, which is loading sbin/init. And this is basically what starts your drivers. If you're on Red Hat systems, that is technically started by systemctl, and there's a daemon that handles that. That daemon or systemctl unit is called systemd-udevd. After that is step 6, which is where systemd processes all the different targets or units inside of a target and starts spinning up system services. Then there's step 7, where the system switches to the root file system. So at this point, all these services are spun up, and then it mounts the file system. Then there's step 8, which is where the system loads default.target. And at that point, you're basically started up and you're in either graphical.target or multi-user.target. So now that we know how Linux systems boot, let's go ahead and walk through how to troubleshoot some basic boot issues with our system. Let's start with interrupting the boot process. We went over this in the last video, where we waited for the system to boot, and then when it booted, we used grub to edit the boot options of our kernel. That is one way to troubleshoot your Linux server. Let's go over that again, and then let's look at the other ways as well. To our right, we have our Linux system booted up into the grub boot menu. So what can we do with grub? Quite a lot, actually. Let's walk through an example. We've already walked through this once before, but let's do it one more time. If we were to hit the E key inside of grub, we would enter the grub boot menu. And if we were to go to the very end, so let's do Control E, and we have hit the end. You see these last 2 lines right here that say RHB, RHGB, and quiet? Those are 2 boot flags that basically tells the kernel to hide boot messages as our system is booting up. So if we're having issues with the system booting up, we would want to remove those 2 messages. Another option we have is to use rd.break. So what does rd.break do? Basically, it pauses the boot process at the 4th stage, which is where init ramfs is loaded. So now let's see what happens when we actually issue that rd.break command. So we do that, and then we hit Control X to force it to boot. As you can see, it's currently booting up. And there we go. We now have our system booted up into not quite the kernel, right? This is a lower level functionality of the system. We would have to mount our root file system from here. Another tool we can use to troubleshoot is to boot directly into our shell from the kernel. So to do that, we would do init equals bin bash. So we would do something like this, equals bin. Remember our bin folders, what holds our programs, and then bash is our shell. So we hit that, and then we force it to start up. And what that should do is force it to start the shell with the root file system already mounted. So let's see what happens. And there we go. And then because we're in bash, we can do stuff like ls block. As you can see, it shows our file systems, and we can modify stuff from here. And you would technically kind of use this mode to do stuff like reset your root password. Another option we have is to boot our system into one of our target destinations. So if we had to rescue our system, or if we had an emergency, we could go back down to this Linux line. We could go to the end of this line and do systemd.unit equals rescue.target. And then we hit Control X and we let it boot up. And it should boot up into rescue mode or emergency mode, and we can do our troubleshooting from there to get this system functional again. Let's give it a couple seconds and see what it does. And as you can see, it is in rescue mode. All the troubleshooting we've done up to this point makes one big assumption. You know what to say about assumptions. That assumption is that your hard drives on the Linux server are actually reachable, that they're in a state that they can be booted from. If they're in a state they cannot be booted from, you're going to need to use a rescue disk. That doesn't necessarily mean you have to walk over to your server and plug a CD or disk of Linux in, but it does mean you have to download some type of Linux installer and boot from that Linux installer. So that could be either a CD or DVD, it could be a network mounted, it could be a network booted image. It could be an image available over your network that you boot using PXE, or it could even be a image flash to a USB drive. All of those would be valid boot options for a rescue disk. So how do you create a Linux rescue disk? Well, you're in luck. I'm about to show you. The first step is to go ahead and download your favorite Linux distro. We're using Alma Linux for this series, so that's the one I'm going to go ahead and download. So you go to Get Alma and you click the ISO image, and then you click here to download the ISO image. Looks like they're having some site problems. Well, imagine you downloaded the ISO image because I already have a local version of this actually. In my case, I already downloaded it, so that's kind of a moot point. You can see the download right there. So with the ISO downloaded, you're then going to need a tool to flash that ISO. You can host that ISO over the network using something like Pixie Boot. You can burn it to a CD, or you can use something like Balana Etcher and burn it to a USB. That's the option we're going to go with. After that, we're going to do another Google search, this time for Balana Etcher. That is my favorite imaging tool. You can use anything else, but this guide is using Balana. So after you search for Balana, go ahead and go to the URL, click download, and we're going to download the Windows version. And now it's time to see if I have a USB. I do. So grab your USB stick like so, plug it into your computer, and then go ahead and install Etcher. We now have Etcher loaded up. Let's go ahead and click that, flash from file, and then choose your Alma Linux file. We're going to select our target. In our case, this target is this USB at the bottom. We click select, and then we click flash. And that's it. That's everything you need to create your bootable USB for your rescue disk. To our left or bottom, depending on how you're watching this, we have our Alma Linux install. So in Alma Linux, we have a couple of options. We have install, test, and troubleshooting. So because we're trying to recover our system, we're gonna go with the troubleshooting option. And as you can see here, we have a couple more options. We have rescue an Alma Linux system, run memory test, install using text mode, and boot from local drive. We're going to select rescue a Alma Linux system. We'll go ahead and let that boot up. And there we go. We're now in rescue mode. And you'll notice this rescue mode is a little bit different. We have a couple options here. Let's walk through them. So at this point, we are in the rescue shell, and that gives us a couple options. So if we were to hit the enter button or hit 1 and press enter, and we wait for a moment, and there we go. It started the rescue shell. So in rescue shell, this gives us basically a bash shell, And then as you can see here, it says your system has been mounted on their mount/sysroot. So we're doing ls block. We can see our files. And if we were to do change root /mount/sysroot, and then we were to do ls, you can see we now have our entire file system there. So rescue mode, we can basically mount the Linux file system and recover files or make changes. And maybe you made a config change that prevented you from boot. You could use rescue mode to boot, mount that root file system, convert back to the old changes, and then reboot your system again. So occasionally you might break your grub install. Maybe you had a bad update, maybe you messed up a config file. Well, one way to fix a bad grub 2 install is to grab your rescue disk or USB, boot into rescue mode, mount the file system, and then from there we can just simply reinstall grub. So we could go here, and since the file system is already mounted, we can do something simple like grub2 install, and then we want to point it at the hard drive that the root file system lives on. So in my case it's going to be /dev sda1. Okay, and there we go. With that, grub2 is now installed. So grub2 install /dev/sda instead of sda1, because we want it on the hard drive itself, not on a partition. Let's talk about the initramfs. If you recall, initramfs is where your drivers more or less are stored. Occasionally, you might get a bad driver update, especially if you're using bleeding edge repos. Let's go with that. That's a good term. So if you're using bleeding edge repos, you might get a bad driver update, and that's definitely going to break your system. In order to get your system booting again, you have to boot into recovery mode, and then from recovery mode, mount the file system, and then run a repair on your initramfs. It's pretty simple. We're already in recovery mode, so imagine we just did one of those steps we've done before, and we have the system pulled up like this. The command to repair your system initramfs is pretty simple. It's dracut. So what we have to do is run dracut -force, and we'll give that a few seconds. And what that does is it basically looks at your system, figures out what drivers it needs, and then loads whatever default drivers are available. And that should normally be enough to get your system booting again. Occasionally, you might lose the root password to your system. Stuff happens, and that's okay. If you ever forget your root password, as long as you have physical access to the system and a recovery disk, we can change that password to whatever we want. Let's walk through that process together. We have our system here, and we're in the brug, and we are in the grub boot menu. In order for us to reset the root password, we have to boot into bash. So we hit E to edit our boot options. We go to the end of the Linux line, and then we want access to our bash shell. So to do that, we do init equals bin bash, and then we hit Control X to boot. And what that's going to do is boot us directly into the bash shell, and there we go. We then have to remount our file system. In order for us to do that, it's pretty straightforward. We do mount -o read write. To do that, it's pretty straightforward. We do mount -o remount. So we're remounting the file system, and we're remounting it as read write, and there we go. And with that, we've remounted the file system as read write, and then resetting the root password is as simple as passwd. And as you see, we just type that in, and there we go. We've just reset our root password. And I know what you're thinking. Cool, we can just reboot now, right? Well, let's see what happens when we actually try to reboot. Let's click reboot. You'll see the reboot command's not found. Why is that? It's like, well, reboot is part of systemd, and we're so early in the boot process that systemd doesn't exist yet. So what we're gonna have to do is basically mount systemd, and then we can reboot our file system. Let's proceed. First, we have to set our SE Linux context. So we do touch./auto relabel. So we're gonna touch auto relabel, and that resets our SE Linux context. Then what we're gonna do is exec user lib systemd. And with that, we just started up systemd. So what did we do? Well, basically, because we're in a different user context and because we've mounted that file system, we messed up our security context. So first we have to tell the system to restore the security context. Then we can start system D, and system D is going to roll through and do all its jobs. And then after that, we can reboot the system. So while it's simple, it is somewhat tedious. So try not to forget your root password too many times. And there we go. And it loads grub and our system booted up. And that's it, boys. That's this video. This is chapter 18, troubleshooting Linux boot, and the different stuff you're probably going to run into if you have to mess with a Linux system that won't boot. Honestly, all of this would be really pointless if you had good backups, right? Backups are super important. They'll save you a lot of this work. But I guess depending on how big that backup is, you know, if you have a VM that's like 20 gigs and you have fast enough network, restoring from backup might take 5 minutes or 10 minutes versus this. But this versus like troubleshooting. But if you did have the troubleshoot, it might take you a couple hours of troubleshooting versus 2 or 3 days of restoring a backup. Because I have seen Linux servers with something like 32 terabytes of information on it. And when I was in the situation where we had to restore that, it took several days. So try not to do that, boys.